I'm Wonderful Dalana, binti Wan Muhammad Rizali, age 1 So I will start with introduction. This study is to figure out what information and the factors are required. Also find out about the information and the way things were gathered and the way things were examined and how it was deciphered utilizing factual programming and how hypothetical models in view of information populates. Next slide is 1.0 data description. This table shows 19 of 150 data, liter per 100, horsepower, weight and brand. 2.0 sample data and record categorical data. For this table shown that 4 variables we use, which is brand, horsepower, weight and liter per 100. For measurement, brand we use nominal, meanwhile horsepower, weight and liter per 100 we use a ratio. Descriptive variable. This table shows the descriptive variable value for brand, weight, horsepower and liter per 100. This variable has been set to organize the data from the departments of Statistics Malaysia. Descriptive and summary statistic for brand. The highest brand is Honda 24%, followed by Opel 21%. The third highest brand is Citroen 13%, Ford and BMW 12%, Datsun 11%, Mercedes 4% and Audi 33%. Next table is weight. The highest percentage of weight is 60% from group 0 until 2.99, followed by group 3 until 5.99, 40%. Next slide is horsepower. The highest horsepower is from group 1 until 1.99, 78%, followed by 0 until 0.99, 15.3%, and the last one is 2 until 2.99, 6.7%. The last number is liter per 100. The highest liter per 100 is from group 4 until 7.99, 51.3%, followed by 0 until 3.99, 44.7%. The last one is 8 until 11.99, 4%.
Assalamualaikum. My name is Nurul Akhlashna Mikir Zahab and my metric number is 818961. I'm going to present my part which is numerical descriptive measure. First of all, measure of central tendencies. Formula for mean is frequency data times with on divided by total sample. For median, the first step is total sample divided by 2 to identify observation. Lower class of median class plus total observation minus cumulative frequency before median class, divide frequency of the median class and then time with the class size. The formula of the mode is lower class of the median class plus changes 1 divided with changes 1 plus changes 2 and then time with class size. So here is the solution. There is all of the data for weight, horsepower and liter per 100. For weight, 2.695 for mean, 2.50 median and 2.246 mode. So it's skewed to the right. For horsepower, 1.408 for mean, 2.439 median and 1.463 mode. So it's skewed to the left. For liter per 100, 4.368 for mean, 4.411 median and 4.489 mode. So it's skewed also to the left. Second, measure of collision. Here there is formula of quarter 1, quarter 2 and interquarter range. So here is the solution. Weight. Quarter 1 is 1.872. Quarter 2 is 4.742 and range is 2.870. Horsepower. Quarter 1 is 1.119. Quarter 2 is 1.760 and range is 0.641. Liter per 100. Quarter 1 is 2.239. Quarter 2 is 6.711 and range is 4.472. And the last one is measure of variation. Here is the formula of sample variance and standard deviation. Solution for weight is 2.174 sample variance and 1.474 standard deviation. For horsepower, 0.2139 sample variance and 0.4625 standard deviation. For horsepower, 5.1751 sample variance and 2.2749 standard deviation. That's all.
Assalamualaikum and greetings to all. My name is Abdul Ali bin Wajid Ahmad. My metric number 821822353. So now we are going to the next part, which is theory modeling. There is a high level association between liter per 100 and weight, liter per 100 and horsepower and weight. There is no clear association between horsepower and liter per 100, weight and liter per 100 and weight and horsepower. For correlation, weight correlates highly with horsepower and liter per 100. There is no significant correlation between weight with horsepower and liter per 100. This situation also has same as the other sample data, which was they have highly correlation and doesn't have any significant correlation. Over the summary, the R-square value is 0.547, which means 54.7% of the variation in brand can be explained by liter per 100, weight and horsepower. The edges R-square is 53.8%. The Dawkins-Watson statistics is 0.334. For ANOVA, the p-value from the ANOVA table is less than 0.001, which means that at least one of the three variables, liter per 100, weight and horsepower, can be used to model brand. For coefficient, the equation brand equal 8.779 minus weight plus horsepower minus liter per 100. Thus, for every unit decrease in weight, brand expected to decrease by 0.230, provided the other variables remain unchanged. Based on the standardized beta coefficient, the effect of weight negative 0.086 is almost 0.05 times that of horsepower 0.177. The p-value for only weight and horsepower are less than 0.01. Thus, only weight and horsepower are the significant predictors of brand. The 19.5% for lower and upper boundary weight and lower and upper boundary horsepower. The VIP values are below 5, indicating that there is no problem of multicollinearity.
Good day, madam. My name is Nur Hasina binti Abdullah. My metric number is 8182846. I will explain about statistical analysis using software. The first part, I will explain about measure of central tendency. As you can see, we use weight, horsepower and liter per 100. At the measure of central tendency, we use data mean, median and mode. So the first number, we calculate manually, and the second one, we use SPSS. So the explanation, the data of mean, median, mode shows the different result because the SPSS read the data accurately. Secondly, we use measure of position for quarter 1, quarter 3 and range. We use the first number, we calculate manually, and the second one we use SPSS. So the explanation is the standard deviation and variance show different result because the error of system SPSS to analyze the data separately, which is the data plus interval is too large. The third one, we use measure of variation. We use simple variance, standard deviation for weight, horsepower and liter per 100. So the first number we calculate manually, and the second number we calculate from SPSS. So the explanation of these three, the result SPSS for data simple variance and standard deviation is not the same as manual because the SPSS cannot read the data accurately.
Assalamualaikum and hi, I'm Aisha Azhara binti Jalani with project numbers A21A2379. So here I'm going to proceed the presentation on the part of hypothesis testing. The hypothesis is a proposition statement or assumption based on some previous observation about the value of a population parameter for testing purpose. In this part, we are using one sample t-test and ANOVA to measure that the hypothesis is reasonable and should not be rejected or otherwise rejected. The first step is H0 equal to 6.29, when HA equal to more than 6.29. Next, the level of significance is equal to 0.05. Step 3 is the output of SPSS, which one sample t-test, liter per 100, horsepower, weight, KPL and cylinders. Then proceed with the step 4, decision rule. It shows reject H0 if T negative TAGF. The critical region is T 0.05, 149 equal to 1.655. Lastly, step 5, which is decision, it failed to reject H0 since T more than TAGF, which is 7.87 or it's 1.655. Conclude that the mean number of its 100 is more than 6.29. Next is ANOVA. Analysis of variance is a collection of statistical models and their associated estimation procedures used to analyze the difference among group means in a sample. For conclusion, on table shows for the decision rule FFA V1 V2, which mean failed to reject H0 since FF 0.05, 43, 106, 2.108 more than 0.05. Therefore, there is no significant difference among treatments. That's all for me. Thank you.
My name is Nora Afika Lintibelia and my metric number is 8218911. For my statistic part, I explain about correlation analysis. For the table that I get from my data, I explain the value of R between brand and weight. I get negative 520C, in which show the strong negative correlation. R value brand and horsepower, I get negative 488, in which show the strong negative correlation. R value brand and liter per 100 is negative 733, in which show the strong negative correlation.
Assalamualaikum, my name is Monica Nosna binti Idris and my metric number is 8182857. Today I would like to present about the confidence interval. For the first one, the mean of brands group is 3.6133, the upper bound is 3.8328 and the lower bound is 3.3939. The difference between upper and lower is 0.4389. For the mean of weight group is 3.805. The upper bound is 3.93985 and the lower bound is 3.77626. The difference between upper and lower is 0.16359. Next, the mean for the horsepower group is 1.3643. The upper bound is 1.4246 and the lower bound is 1.3041. The difference between upper and lower is 0.1185. The mean for the liter per 10 group 6.292. The upper bound is 6.5144 and the lower bound is 6.0840. The difference between upper and lower is 0.4304.
As a conclusion, for the method, there are several methods were used to calculate the data of the values of the descriptive variables for brand data per 100, horsepower, and weight based on the data population in Malaysia, such as data arrangement, graphical representation, a measure of central tendency, a measure of variation, and a measure of position. And for graph, there is 4 types of graph were used, namely bar and pie chart, histogram, and OGIF. For the manual calculation, the measures of central tendency were used to calculate the mean, median, and mode for weight. The quartile method was used to calculate the interquartile range, which is 2.87 for the measure of position. Then for a measure of duration, the standard deviation that has been calculated is 1.474, and the shape of the data distribution is skewed to the left. While for the SPSS calculation, the result was very different because SPSS cannot read the data accurately. The mean, median, and mode produce disparate results. The relationship between a theoretical model and a regression model, as well as how a regression model can be used to test and clarify the relationship in a theoretical model. The distribution shape can be classified into 2 categories, namely symmetric and non-symmetric. Last but not least, statistics have a huge impact on all facets of life. Thus, it's critical to grasp them in all the courses and fields we already covered. That's all from us. Thank you.